Right. Um, Go. Plan Prime Mover. So, I played a few levels before. Prime Mover is a game about solving problems. This is where the problems are displayed. Top right, okay. Create solutions on the board, sure. Left click to place wire. Right click to delete wire. Click to turn on the machine. Okay. Machine off. Connect C and D by clicking and dragging. Okay. Okay. Sweet. So what do we got? You haven't unlocked a new component. Click here. I can use hotkeys 1 and 2. Oh. Send A to D. Probably read the instructions first. Send A to D and then send B to C. Right. Oh. Okay. Cool. Right. Relay. Send A to C and then send B to C. So we're going to send A to C. And sends multiple inputs in a direction. Click to rotate. Middle left mouse to rotate. Hover over it, got some. Okay, sends multiple inputs in a direction. Click to rotate. Okay, so if we try and connect these, you can't connect two or three wires together, I guess, right? So this can connect to this, and then this can connect to this, but not both at the same time. That's where this comes in. I can connect these. Let me make this. Right. An A to C and then some B to C. Perfect. And then if you, like I said, if you hover over stuff, it'll give you instructions. So if I hover over this, right, drag to connect components, click to toggle fast and slow wire. So purple is a slow wire. It'll obviously go slower. So if I need to slow down one side, I can do that. Again, so I've never beat the game, but I have played, you know, the first, I don't know, 10 levels or something a while ago. So I'm a little rusty, and it's also 1 in the morning. But you know, here we are. Amplifier send A to B and C. So this is going to duplicate an input from a direction and outputs in all other directions. Okay. We'll send A to B and C. Okay. That's sending A to B and to C. Straightforward. Okay, unlocking this. Am I supposed to be able to read this or no? All right. I believe this pulls up the video we just watched, so I'm not gonna pull that up. Separator. Okay, so A is never okay. For a solution to be valid, there can be no numbers left on the grid. Okay. So A is never negative. If A is positive, send A to B. So if you can kind of scroll through the inputs here, it's either going to be a positive 1 or a 0. This sorts. Okay, so this is obviously we're going to need to use this. And then this deletes all inputs. Okay, and so the note said not to bring it back up real quick. For a solution to be valid, there can be no numbers left on the grid. So we have to delete anything that's not positive, basically. So delete all the zeros. So if we put this here. Okay, then we need to rotate it. There we go. Okay. So assuming if something comes into contact with this, if it's positive, it should shoot out to the left. If it's negative, it should shoot out to the right. And if it's 0, it should go down. So we want to delete all the zeros, right? It says if A is positive, send A to B. And then we need to reverse this so that the positives shoot out to the right. Right? So that should work. Yep, all the zeros are getting deleted and all the ones are going to the right. Perfect. Alright, distributor. Send every other value of A to B and D. Every other value. Okay, so you look here, the 1 should go here, and then the -5 should go there. So the first number is going to go to B, the second one's going to go to D. This toggles between 2 wires. Okay, so every time something... What's this? This lets you kind of go frame by frame, step by step, right? So 1 is going to the right, and then this switches, and then this goes here, and then it switches back. So every time something passes over this, it's going to alternate, okay? But we want the 1 to go here, so we need to set it to this side first, and then just connect the tracks, right? The 1 should go up. Perfect. And then 5 should go down. Right. Pretty straightforward. Transformer. Alright. Send A plus 1 to B and send C minus 1. I'm sorry, what? My brain is not working. Send A plus 1 to B. I'm not doing this in the right order. I must be. Okay, so send A plus 1 to B and send C minus 1 to D. So this adds or subtract 1 to an input. Click to rotate. Okay. So send A to B and then C to D. So, yep. So 5 is the first. Oh. 5 is the first number, right? So it should A plus 1 to B. So I need to add 1 to 5. That turns into 6. Yep. 7 turns to 8. 1 turns to 2. Yep. So 6, 8, 2. Perfect. And then this is send C minus 1 to D. So I need to switch this by clicking the middle mouse button. And that should subtract 1 from everything. Yep. 2 is going to 1. Yep. So we can just play that through. Easy. Cool. Right. Checking, making sure camera looks okay. You can see me. I don't have a light, really. My overhead light is kind of behind me. So I just turned up the brightness super bright on my monitor. Yeah. All right, so pretty cool, pretty cool. Flipper, click here to select a new component. Place the component here. This is what the component is targeting. Okay. Click middle left mouse to change the target. What changes its target component when a number passes through it. Okay, so the button switches things. Okay, interesting. So add 1 and subtract 1 to every other value of A, send A to B. Okay, well, obviously I need the... Oops. Need the wire. And... Okay, but it's got to pass over this. Okay, so... So the first number is 5. And we need a 6. The next number is 6, and we need a 5. So we're going to add 1 to the first number. And then it's going to hit the button, which is going to switch this. And that should alternate every time. The 5 gets turned to 6, yep. Passes over the button. 6 turns to 5. Nice. Yeah. I wasn't sure if I would need to do... Because it's... The number is on the button already. Or on the plus minus thing. So I wasn't sure if that would be too quick. But it looks like it's working fine. Just to kind of explain what I mean. I thought... I'd have to do something like this, potentially. Where... maybe I slow it down like this. To kind of illustrate what I mean, right? Oh, hold on. So the 5 gets added, right? And then this... That doesn't even work. Never mind. Let me shut up. Let me just go to the next problem. I've been up for a while, so my brain is not too sharp right now. Gator, send A to D and then send B to D. So A needs to go to D first. Okay, there's only one number in each. Okay, I have a lock. It can either be locked or unlocked. Automatically locks when a number passes through it. Click to toggle. And I'm assuming I can't. Okay, so we're going to need to do this. There's the toggle. So, I'm assuming I can't. It has to be automated. So I'm assuming I can't just toggle this. Yeah, I can't click it right now. So the 1 goes in first, and then the 2 needs to go. So what I need to do is I gotta have a button here, right? And so that should unlock this. Boom, now it's unlocked. Oh, but the 2 goes in first. Okay, so I need to have the button closer. We'll put the button here. That way it hits the button and then immediately goes next. And then we'll have the lock here. And so it's gonna have to go to this square first and then go down. That should work. It's gonna, number 1 from A is gonna click on this button, which is gonna unlock this. So the number B is gonna be here. B is gonna go to here. A is gonna go to there. It should just work out like that. Boom. Unlocked, perfect. Cool. All right. Unlock. Am I supposed to be able to read that? Am I too tired? Like, is that English? I don't know. It's cool graphics though. Very cool. Alright, differentiator. Let me just double check. Yeah, okay, that's the... Okay. Time to go to bed, I think. Differentiator. First, output all of A to C and D, and then output all of B to C and D. Okay. So that I can do something like this, right? So we're going to have A. A is going to go here. Right? And then B is... I have to do something like this. B is then going to go... So, okay. Output all of A to C and D. So this is going to duplicate all the inputs from A. So we'll just start with this. So one goes here, and now there's two ones, right? One in here. That's going to go to C and D, right? Now we need B. So it says output all of A to C and D first. So all of A. And then I have to output all of B to C and D. So what I can do is do like a slow wire. And then that. We can do something like this. Alright, so all of A should go to C and D, right? We'll slow that down too. Slow down these. And then B should be able to go to C and D as well. So we'll go ahead and connect these like this. Oh wait, what am I doing? I guess I don't even need this, huh? I can just do something like this. So A should input first. I got all this slow wire. Yep, so A's first. And then I can probably get rid of some of these. A little excessive. Okay. And perfect. I did that in 30 ticks. Apparently I did it in 27 once when I first figured it out, so there's a faster way. Just maybe get rid of some of these slow wires. 28 ticks, nice, closer. And then this is your chip. So this is what do you call it? A histogram. I don't know if this is all. Well, it has to be, right? Because I only have me and one other person. I'm Tony B, obviously. But there's several numbers here, so this must be the best score-ish. 28, 27? I don't know. It's close to it, I think. And then I did it in 4 chips, so you can do it in 2 chips. So how would you do it in 2 chips? We'll keep this solution. We'll go up to a new save here. So these don't count as chips, right? These are tracks. It's just these, and this doesn't count either, I believe. But these should count. So instead of having one here and here, I can only have. Obviously, I need at least one of them to combine the B and the A tracks onto the C and D tracks. And then I guess I only need one of these. How does this work? Can I do it in one? That'll have all of A go to the here, right? And then if I do something like this, ooh, disconnected here. Okay, okay. So here's where I would need to do something like this. And then we'll do some slow wires here. So this is only using 2 chips, and this should, in theory. Yep, so that's all of A went first. And then it all gets duplicated and goes to C and D. Perfect. 31 ticks is kind of slow, but only 2 chips. So I don't know if you can optimize for both at the same run. Maybe you can, but it's fun to give a little extra challenge to yourself, you know, especially on these easier levels. All right, alternator, send A to B, and then you're going to add 1 to every other value of A. So looks like the first value is 3, first input, and then the first output should be 4. So you're going to add 1 to 3, and then you're going to turn off adding for the 45, and then you add again for the 5. So add 1 to every other value of A, starting with the first one. So we're probably going to do something like this, right? And then we'll add that. Oh, I guess I got to do something like this. Okay. And then we'll probably use something like this too. So we're going to add 1. We're going to go into this thing. We're going to add 1 to this first value, and that's going to go here. And then this should alternate. And then for that second value, go to there. So 3 is the first value. We need a 4. 3 turns to 4 there. Boom. Track switches. Ooh, that's a little... We got lucky that the one going up goes first. I don't know how it decides priority there. Looks like they both should go at the same time. So that kind of worked, but there's probably a better... They did it in 24 ticks. Chips. That faster? That's exactly the same. I don't know. Maybe I can... like this. I don't think that's any faster. 7 ticks. Oh, wait, hold on. I hit the wrong button. Okay, so we'll just keep this for now. Maybe the problem is I'm just going too far. Like I'm going down for no reason, so let's just not go as far down. I'll just stay on the second row as opposed to going down to the third row. So, change this to this, connect those. And then we're adding one, right? Start with that first one. 25. Still not the 24 that I got somehow, but that's close enough. Alright, integrated circuit, send D to A, delete every other number. So I don't have a lot of track to work with here, so I kind of have to just do something like this. Okay, and then it's highlighting this. Left click to open new board inside. Oh, shoot. Okay, I get why it's called integrated circuit. Okay, so send D to A. We're starting here, sending D to A. And then delete every other number. So the first input is 33. We need that 33. So we're going to keep the first one and then delete the second one. Keep the third, delete the fourth. So we'll just start with this. And then we'll just go here. So this should connect to that, right? You connect the right side to the left side. And then this left side, all we have to do is delete all inputs. We're going to start off with the first one going here. They'll switch, delete, and then go back and forth. That should work. We can actually open this and see what's going on here. Cool. Those 38 ticks. 3 chips looks to be as you know, optimized as possible, but ticks wise, what can we make this better? I don't see how to. Can't really make this fat. Oh, you know what we can do? We can move it. So instead of having to travel all the way from one side to the other, you can just travel from here, which is like 5 blocks over here, right? 1, 2, 3, 4, 5, whatever, 6. But should be faster that way, I think. And then we'll do the same thing here. Start off on the right, go up, and then just delete here. That should be faster. 36 ticks, perfect. All right. Now we're getting some of my resets. Okay. Send A to B. Reset will block input until you have completed the problem for the current set of data. I'm not quite sure I'm following. Block input until you have completed the problem for the current state. The state of the board resets to initial state when reset unlocks. Okay. We'll send A to B. Send C to D. Okay. So 4, 1, and 2. 1 input from A, 2 inputs from C. And then reset happens. Okay. Alright, I get it. Alright. Lock. Interesting. Oh, and I can just pick whichever one I want. I don't have to start with... I don't have to unlock them in order, I guess. I don't know which one to start with. You now have access to all components. Press Z to undo. Press Y to redo. Is that normal? Is that like the standard, like control? Control Y. For now on, every problem will be a big challenge. Okay, alright. We unlocked the real game. So we're going to generate all numbers from D to 1 in order, and then send them to B. So if you look, 10 is the input, and then there's a reset, and then 35. So we're going to have 10 go through, and then the output is 10, 9, 8, 7, 6, 4, 3, 2, 1, right? Reset, 35, and so on. So we don't have to worry about any extra inputs coming in, having slow wires and things like that. So that's nice. Reset's kind of good for us there. We need to generate all numbers from D to 1 in order. So obviously we need to take 10, subtract that, and then that'll give us 9. Subtract that, that'll give us 8. But we need to save that 10 input. So we'll start with a duplicate, right? And so this 10 should go to B, right? And then we'll do something like this, maybe. The 10 will go here. And then we need to subtract 1. Subtract 1. And then that will go here. Probably gonna need something like that. Oops. So we'll probably just... No, that won't work. especially with like 35 and things like that. I was thinking we could just have these go all across the top of the... Okay, so we need to do it a different way. We need to do like some kind of loop. So how do we do that? So we'll... Okay, so this will be like the end of the loop, right? Okay. So first, we're gonna duplicate, right? So we're gonna take that 10 input, and we're gonna send that off. Something like this. So we're gonna take this 10 input. This is just to complete the loop, right? So we're gonna send this input to B, right? Send this input to B. And then this input... Oh, we have too many things. Okay. Shoot. So, start over here. We're going to send one input off to B. I'm not gonna lie, I'm stumped. I'm stumped. So it's gonna be some kind of loop, right? And then every iteration of the loop is going to subtract 1. And then at the same time, it should send off so we can do 3, right? Okay, so I think we're good. No, wait. Yeah, okay. So maybe we just need to start the loop with this, right? Does that make sense? And then, yeah, okay. So this is the loop. Right, okay. So, we're going to take the number 10 here. It's going to go in here. And it's going to hit this duplicator block, right? So that's going to send a 10 in this direction towards B, right? It'll take another 10 and send it here. And then this block will subtract 1. So that's going to turn that 10 into a 9. And it's going to loop around here, right? That 9 then gets duplicated, right? One 9 goes here. The other 9 gets subtracted, right? So this should, in theory, work. Okay. Perfect. Just accelerate that. Oh, wait, whoa. Okay, now we got a problem. So it's not stopping. It's supposed to stop at 1. What game is this? This is Prime Mover on Steam. Go to the store page. It is $15. You know? That's not that bad. It's a fun game. I'm probably gonna upload this to YouTube. So if you wanna, you know, or like I guess the VOD will probably be on Twitch too. But you kind of missed the beginning explanation. But there's all these components, these tracks, and you know, you're trying to complete these instructions in the top right. Yeah. Yeah, it's a tough. I mean, I'm confused, and I played the tutorial, so you know. So we need to generate all numbers from D. So starting at 10 to 1, and then it's going to reset, and then do 35 to 1. So we have this duplicator, which is sending a number to B and then also sending a number this way, and then this is going to subtract. But we need to add another component that stops the number at let's see. I don't know. So obviously if it's negative, or we can even stop at 0, right? So if it's 0, should never get to negative. But this block will delete anything that goes here. So anything that's 0 will go up and then get deleted. Oh, oops. Now, the question is this in the correct position? Like, do I need to have it before the duplicator? So, we'll say a 2 goes through here, right? Gets duplicated, subtract a 1, goes to 1. 1 is not 0, so it won't get deleted. It's positive, so it should shoot out to the left, follow this track. Now we have a 1. 1 gets duplicated, gets sent here, which is perfect. 1 gets subtracted, so now you have 0, and then 0 gets deleted. So that should work. So 1, boom, gets duplicated. 1 gets subtracted, so that's a 0. 0 goes there, 0 gets deleted. Perfect. And then it should reset. So, okay. Perfect. Awesome. It took me 525 ticks. Apparently I've done it in 198. Oh, also you missed the explanation. I played this game before, like years ago. I don't know how many levels I completed. Definitely not the whole game. So that's why you see some of my scores here. It's possible to do it in 121 ticks. 5 is the least amount of chips. So I'm going to see if I can try and optimize this and just do another solution. So this is... I think this system is good. But you can do like a cheesier system where you send out multiple inputs. So instead of sending, 10 through here once, I can send 10 and then 9 and then 8 and then like at the same. Maybe? I don't know. Am I crazy? Am I insane? So what would that even look like? Okay, let's go back. So the system is one of these, right? This is a, you can't connect 3 tracks. So this kind of lets us connect 3 tracks. That's what this block does. Sends multiple inputs into one direction. So I can put 2 inputs into this and it'll send it out into a third direction. So I have one of these blocks, I have a duplicator, I have a subtractor, and then this checks the value to make sure I don't go negative or to 0. So if I wanted to do this faster, 35. 35 is the maximum value. I don't know. I'm actually going to give up. I'll come back to it. All I care about is I found a solution. I can worry about optimizing later. All right. Sign. B is never 0. B is this input up here on the top right. If B is positive, we're going to send 1 to D. If B is negative, we're going to send -1 to D. What? It's 2 in the morning. Okay, so B is never 0. So we don't have to worry about B being 0. If it's positive, we're going to send +1 to D. If it's negative, we're going to send -1 to D. Oh, this is going to be tough, isn't it? This is going to be tough. All right, so we're going to have B here, right? And I feel like we're going to need to use that clock thing that we designed on the last level. So if B is positive, we're going to first check to see if B is positive. And again, it said that B is never 0, so we can use the 0 side as the input, I guess. So if B is positive, we're going to send +1 to D. B is positive. Send 1 to D. And then if B is oh, well, that's cool. There's a spam comment, and Twitch automatically blocked it. Okay, so if B is positive, it'll go down this track, and then we need to turn that positive number into a +1. If B is negative, it's going to go on this left side here, and we need to find some way to turn that into a -1. So we're probably going to use that clock thing again. So we started off with one of these, and then we okay, so first we need to check to see if it's a 1 already. So we don't want a 0. So if we get a 0, we're going to delete it. It obviously won't be negative because this is the positive track, right? So it's already checking to see if it's positive here. So we know it won't be negative. So if it's 0, we're going to delete it. If it's positive, we don't have a way to check to see if it's a 1. We just know if it's positive or not. We don't know if it's a 1. So what if instead of having a 0, so if we get a 0, we can just add 1 to it, right? And then we know it's 1. So if it's positive, all we have to do is subtract it, right? Boom. So let's say it's like 10, right? If it's 10, it's positive, it'll go here, we'll subtract it, and then we can loop around, right? So 10 comes through. If it's obviously no negatives will be here. So if it's 0, it's gonna go here. If it's 10, it's gonna go here, get subtracted, right? So now we have a 9, it'll loop around. Now we have an 8, etc. Blah blah blah. We get all the way down to 0. Once it's a 0, now we can add 1 to it, and now we have our 1. I probably should do this differently. I don't know how to use this tool. I guess we'll just leave it like this. It's fine if it's not optimized. Right? So if a positive number comes through, it'll subtract by 1. Eventually that positive number will turn into a 0, and then we add 1 to that 0, and now we have a +1, right? We can do the same thing on this side. So we know for a fact the number won't be positive because this is the negative side track, right? We're checking to see if the number is negative. A negative number is going to come through here. All right. We need one of these to start it off to get the loop going. So if it is, oh, whoops. First day having hands, sorry. So if it's negative, we're going to add 1 to it. That's the wrong button. We're going to add 1 to it. And then we're going to send it back to the loop. So eventually we'll get, if we keep adding 1 to a negative number, we'll get a 0. And then once we get that 0, we can subtract 1, right? Because it says if B is negative, send -1 to D. So we can subtract 1. And again, this is like, I should just have it aimed down, but my brain is not working, so I can't. Don't worry about all that, you know, like it's fine, it's fine. So if we test it, right? Oh, wait a minute. Wait a minute. Wait a minute. I banished the ads for a minute. Might need to be updated on our puzzle. Okay, let me know when the ads. Okay. You're back. Okay, sweet. So if B is never 0, right? If B is positive, we're gonna send +1 to D, right? If B is negative, we're gonna send -1 to D. So what I have is the 0 is gonna come in here, and then it's either gonna be positive or negative, right? Never 0. If it's positive, we need to send a +1. So we're gonna check to see. Obviously, we know it's not 0. It's gonna be some positive number, and it's gonna subtract 1 from that number, right? So let's say it's 10. 10 will come through. We're going to subtract 1 to get 9. It'll loop through. 9 will go through because 9 is positive, right? Subtract 1. It keeps subtracting 1 all the way till we get to 0. And once we get a 0, we can add 1 to it. So if we get a positive number, it's going to go into here, and then a +1 should come out. Same thing on this side. If we get a negative number, it'll we'll add 1 to it until we get to 0. And then we'll subtract 1 to get the -1. So if B is negative, we're going to send -1 to D. So if a positive number comes through, it'll turn that into a 1 and go out here. If a negative number comes through, it'll turn that into a -1 and we go out here. The problem is, I was used to the reset thing. And so if it's a really big positive number, it's going to take forever in here. And then the second number is going to go through really quick and go through. So I need to find some way to slow it down. Oh, you know what I can do? So I can have a button, right? So we're going to have a button here. So as soon as we're done sending a +1 or a -1, that number will pass over this button, which will unlock the next number. Is that enough track? Maybe I need to put it a little higher. And then obviously the first number to come through, I can set it to unlock. So a number will come through that'll automatically lock afterwards. The button here. Boom. And now we just need to set up the circuit here. So we can go ahead and delete all these. That's the wrong thing here. So I need to first sort the numbers. And then we'll have something like this, which will feed into the numbers. So if the number is negative, we want it to go down, right? We want it to come out here. So the number is negative. We want to turn that number into a 0, subtract 1 from it, then output it down here. Oh, did I do this wrong? Yeah, we already checked the numbers, so we don't need to check it right away. There we go. Alright. So a negative number is going to come through here. We know the first number is going to be negative. And so we're going to add 1 to that number. And then we'll send it back through the loop. So eventually it'll turn into 0. The 0 will turn into a -1 and then shoot out through the bottom here. Boom. Now if the number is positive, same thing, right? Oh. We want it to come out the left side of this circuit and then go out the right. Inputs on the left, outputs on the right. Oh no, sorry, output is up. Okay. So we need to take a number. We need to make it a 0. And then we need to add 1 to it. Once we have a 1, shoot it out the top. And again, because we know the number is positive, we need to subtract 1. And then send it through the loop. So now we're cooking. Now we are cooking. The first number is -18, so that should go to the left, right? Now we can enter here. This -18 obviously is negative, so it's going to go through here. We're going to add 1 to it. And then it should loop. Right? 17 still negative. Speed that up. Now we have a 0, right? And that 0, what? Subtract 1, right? So if B is positive, send +1 to D. Because the first number was negative, we should send a -1 to D, right? So now that -1 is going to unlock the next number in the sequence. Right? Yep, perfect. Next number is a -1, so that should go through relatively quickly, right? Nice. Next number should be a +1. So +1 is the input. I'm going to turn that into a 0. And then add 1. And should come out the top. Unlock the next number. Boom. Okay. Nice. Big. Alright. Obviously, it took me a lot of ticks. There's probably a better way to do it. You could probably subtract by 2, right? Is that possible? I'll just quickly look. So if we subtract by 2, we could get a negative number in here, which will shoot it out to the left. Could you just have multiple checks? So let me just first copy all this. That's such a useful tool. Okay. So here's what I'm thinking, right? Something like this. Right? We just do... something like this. Oh, maybe we can't. Can't do that last one, I guess. So basically, instead of having to loop around twice, you should be able to just do it faster, I think. I don't know. That could be faster. In any case, it's not that important. We'll just do this. I'm curious if this is faster. So we'll just do another check here. It's oriented the same way. That should still work now. That is much quicker. Okay. Sweet. All right. Let me try one more, I think, and then I'll go to bed. Flow control. If A is the number 1, we're going to send B to D. What? How do I do that? Okay, if A is 0, we're going to send C to D. Then delete all values of A. Okay. So we're going to have one of these, right? I think. And then we're going to have a... What? Ooh, I might just have to call it here. I don't know. I literally have no clue. So I was thinking we could do like a button, but like I don't even know how that would work. I don't. Yeah, I mean, what? But like, what is that? Like, okay, so maybe this, right? So the input's gonna come here, and then it's either gonna go out to the left or the right. And then we'll have A somehow go here, right? And so if A is 1, then we're gonna switch this. But then every time something passes over this, this switches too. So I need to like. Yeah, no, you're good. You're good. I mean, we're probably at the same level of understanding, at least on this puzzle. So yeah, just to explain how this works. So anything that passes over the button will like activate this. So like if you have this here, every time something passes over this button, it'll switch from left to right, right? So I can switch things that way. Same thing with the lock, right? Anytime this button is a number passes over the button, this will lock or unlock, right? And then the lock, anytime something passes over it, when it's unlocked, it automatically locks. So it automatically defaults to lock, being in the locked position. Same thing with this, right? If the button goes over this, it'll switch from negative to positive. This is a circuit. So it just gives you more space to work with, I guess. This is a duplicator, right? So if you got 3 tracks, it'll take input from one and then send something out to the other 2. This, if something's negative, it shoots out to the left, 0 shoots up to the top, positive shoots out to the right. And then this just deletes stuff, right? You're not allowed to leave numbers on the board. So this is let's see, knowing all of that, what do we do here? What are we thinking? So if A is 1, so first we need to be checking if A is either positive or 0, and we don't have to worry about it being negative, so that's nice. So we'll just do something like this, right? So if A is 0, we're going to send C to D. If A is 1, we're going to send B to D. I'm so confused. So like, how do I even start? So are there 2? Okay, so let me just look at this. So D is where all the inputs are going, right? So the first number on D is 8. So if A is 1, which A is 1, then send B to D. So this 8 is going to go to D. And then if A is 0, which the next number is 0, we're going to send C to D. So this 8 from B is going in first, and then this -1 is going in next, and then the 0 goes in next. What? So all of the... We're not deleting anything from C or from B. We're only deleting the stuff from A. Okay, that's fine. So there's going to be something like a button, right? And then we're going to delete the values from A. So good lord. Good lord. If A is 1, send B to D. I feel like the instructions are misleading. So do I need like a line? Like a queue, right? So if A is 1, B would be the first number in the queue. And then since A is 0, the next 2, then C is the next 2 numbers in the queue. I'm too tired for this. Genuinely. Okay. So let's get something on the board, yeah? Let's just try something. So if A is 1, we'll say we'll hit this button. Okay, let me look at some more inputs first. So we have 1 0 0, so that should be 1 input from B and then 2 from C, right? After the reset, we then have 1 0 1 1, right? So 1 0 1 1. So we're gonna have one number from C. Or sorry, one number from B, one number from C, and then 2 more numbers from B. I don't know. I don't have the faintest clue how to even start. What? That's cool. You can kind of click on some stuff. Okay, yeah, I don't have the faintest clue how to start this. Flow control. Okay. Okay, so if A is 1, we're going to send B to D. I just putting on this to the left side because the inputs are coming from the kind of middle, I guess, and D's the output, right? So it doesn't make sense to have it on the right side. All right. So obviously the inputs should there be a couple buttons on B and C to unlock each number Q based on the value of A? Yeah, the Twitch ads are crazy. Um, I, I I think I just need to. I can turn it off, like have no ads for the hour, and then it'll just play an ad when you open the stream, and I think that's it. So I think that's probably the ideal. Okay, so you're saying should there be a couple buttons on B and C to unlock each number Q based on the value of A? I mean, yeah, I think so. It's on B and C to unlock each number Q based on the value of A. So the value of A is determining what number goes through, right? So the button should be, I don't even know. Do not know. So, yeah, okay. So, let's do something like this, right? And then we'll do something like this. So, B and D are both going to be... Sorry, B and C are both going to be locked, right? You're a genius. You are a genius. So, yeah. So, B and C are both locked. If A is 1, it'll go to B, right? Which will unlock it. If A is 0, it'll unlock C. So that should just work, right? A is 1. Boom. Unlocked. Nice. Nice. Well done, well done. And that's like pretty close to perfect too. I guess you can do it with less chips, but nice. Nil cleaner. Send A to B and remove every 0. Okay. That should be easy, right? So if it's 0, we're just going to delete it. And we'll send A to B. Ooh. 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 Wait a minute. So A is negative and positive. Okay. That could be a dilemma. Okay. Okay. Wow. Okay. This is going to be tough. All right. So we need to send A to B. And if there's a 0, we need to delete it. You know? The problem with the sorter is if it's negative, like, so we can only have 3 things attaching to it, right? So I can't have 4 inputs. So the problem is we have zeros, negatives, and positives. So wherever I insert it from, it's just going to shoot it back out the other way. So I need to find some way if I can find some way, like, so let's say the input's coming from the negative, right? Input's coming from the negative. if I get a negative number, it's going to shoot back out. Wait a minute, wait a minute, wait a minute, wait a minute. Wait a minute. Okay, so what if... So I can't get rid of negatives, and I can't get rid of positives, but can I get rid of the zeros? Here's what I'm thinking. Here's what I'm thinking. Maybe I do some kind of loop, right? Wait a minute. I don't know. I thought I was cooking, but I don't think I'm cooking. Nil cleaner. All right. So first, let me just lock the inputs, right? So the first number is going to get through. And then we got to unlock it afterwards. So after the number unlocks here, we'll have it get deleted. So we'll send a number through. We'll somehow duplicate the number. And then that will unlock the next number while also sending it through here. Right? So we'll have an input. We could probably we don't even need this actually. If we just do something like that doesn't work. My brain is small. All right, so the number will go through here. We'll do some calculations to it, and then it'll unlock the next number, and then go through here. So we don't have to duplicate anything. So that'll save us a block or a chip. So we need to find some way to get rid of all the zeros. And we're limited in our ability to use this block because we have negative zeros and positives. So what we can do is potentially maybe we can just add. Before we get a zero, can we add? So remember that clock thing we built before, right? So we can't have this here yet. Because it'll just get sent back. So we can add one in theory. So, okay, let me just copy this for a second. It's down here. So what happens if I do something like this, right? If I add a number, and then I check to see if it is negative, positive, or zero, right? So if the input is 0, it's going to add 1 to it and do some nonsense, right? Whatever. We're not too worried about this. But if it's negative, Okay, we'll start it this way. If a number is positive, so we're taking 0, we're adding 1 to it, so now we get a 1. It'll go here. We'll actually do some slow wire here too. Just to... If we add a number... I just want to see how this works. So we take a positive, or we take a 0, we add 1 to it, so now it's positive. Now this is positive, and it should send back this way. Now will it add another one? No, it doesn't. Okay. Interesting. Good, move that back. This is a tough one. I might have to call it here. Send A to B and remove every 0. What can we do here? I definitely feel like we're going to need some kind of loop system here. And so what that will do is, if we have some kind of sorting thing where it sends it back, it'll hit this and then go back. So, just put it here for example. So if we add 1, right? And then we sort, we want the positive to go back this way. This is just to help block the numbers. So we take a 0, we're going to add 1 to it. Now we have a positive number, and the positive number should go back to the left. What happens now? It goes back to the left. It does add 1 this time because it can move. And then goes back again. So this will actually help, I think. The problem is this is going to keep going up forever. So this will change the direction, but if I use this block, I can send it back the right way. What if I use some kind of duplicator block, right? And then that sent an input to a button, and that button changed this direction. So hear me out, hear me out. So we'll do something like this, right? So a number is going to come through here. It's going to get duplicated. And that's going to send our counter, right? So this is like a... Oh, maybe we should duplicate it first. So we're going to duplicate this. So every time a number comes through, we'll have another extra input to do something with, right? So what we can do is, if a number comes through and it's the wrong direction and it just gets stuck in a loop here, we can have a button here. actually even go longer here. And then we'll have a deleter here. So it's just going to delete this input. So, oh, wait. Shoot. There we go. Okay. We might have some problems later. Might have to do something like this. Or I guess we can just move this all down a little bit. We'll delete it here. Oh wait, we don't need to delete anything here yet. Okay. So once the number gets through this, so if a number is a 0, it'll get deleted here. Now, so zeros are taken care of. The problem is if we get a number that gets stuck in this loop here. So this duplicator will send an input to this. Got the slow wire here. So let's say a negative number comes through. Negative gets sent back out to the left. This sends it back out to the right, gets stuck in a loop. This duplicator will take an input, and if this is stuck in a loop, it'll hit this button, and then that'll get deleted. So what'll happen now is this should get switched by the button. I think that's how that works. So the 0 still gets deleted, but if it's negative, it'll switch and go this way. Now, the problem is, or I don't know if it's a problem, but if the number is positive, well, it should just get through anyways the first time. So it should be, this should work. This should work. So first number is 0. This block now becomes locked afterwards, right? So nothing can get through. We're going to send this 0 through. And a 0 should get deleted. Oh, that's a problem. That's a problem. If the zeros get deleted, nothing's unlocking. Oh, no. Nothing's unlocking the next input. Oh, shit. Okay, but if we have a positive number, it should go through, and then this button will get switched, right? And then this will switch to this. And then, you know, if the number is positive, it'll get stuck in a loop, but the next one should. So this all should work. I just need another way to unlock this. If the 0, so can I just delete the 0 later? So what if I do something like this? So no matter what goes through here to unlock the button, we delete it afterwards, right? And this is definitely not the correct solution. So anyways, the zeros will get through. They'll unlock the next item, and then they'll get deleted. But we do need to send correct inputs. So we do something like this. Can I do that? No, I can't. No, I can't. Okay. All right, so we need to, so this should take care of the negative positive problem. The zeros are still going through and unlocking the next number and then getting deleted. I need, there's probably an easy solution for this that uses more chips, right? Do something like this. Do something like this. Alright, so zeros are going to go through here. unlock the next item, and then get deleted. Meanwhile, the correct input should just go through here. So zeros will come through, get duplicated, get deleted, switch this. 0 will go through here, go up, and then unlock the next item and get deleted. So the next item should get unlocked. Positive numbers will come through, get stuck in a loop here, but there'll be another thing to unlock the button, which switches this. So now the positives can get through. The extra input will get deleted. Positive number will get duplicated, set to the to B, and then also the other duplicated input will come over here, unlock the next item, and get deleted. So this should work. This should work. All right. 0 locks, duplicated, goes through, unlocks the next item. This gets switched, and also that 0 gets deleted. -1 makes it through. I think this is too slow. All right. Nice. Yeah. Okay. So -1. Obviously, negative goes through. No problems there. This will switch the button. Negative unlocks the next number. Positive 25. Positive gets through. Now, the positive is switched. So the positive should get stuck here on this next one. The positive gets stuck in the loop, right? But we have this button. Switches it. Gets deleted. And then lets it through. And we should be good, right? 0 gets deleted. Yep. I think we're good. Thank you. And it, like, Race did it in 139. How? He only used 8 chips. Like, I definitely think you have to have these two, right? And then you have to have a button that switches this. There's probably just a faster way to do it, and then you. But I mean, this is good for 3 a.m. This. Thank you. All right, I'm definitely gonna call it there. Thanks for tuning in. Yeah, I'm probably gonna upload this to YouTube. I don't think I'm gonna edit it because I'm lazy and I don't really know how. But maybe someone gets some entertainment out of this, you know. Yeah, thanks for watching. You have a good night, and I'll see you later.